Okay, today we are continuing with our agriculture, which is part of Unit 4, AP Environmental Science Standard Land and Water Use. We're still looking at feeding a growing population. So previously we talked about the human population and the nutritional needs of individuals within those populations. This requires that we understand how we actually come about feeding people. In order to feed the world population, we rely very largely upon modern agriculture. Agriculture, however, is not quite as simple as we think of it. There are many types of agriculture, and there are many types of agricultural methods that we use to produce food both for human and animal needs, because remember, we consume many animals that also must be fed, and so we have to meet those animal needs as well. So while the actual range of agricultural methods is very large, we're going to concentrate on the most common types. There are 10 very common types of agriculture. We'll discuss each one individually. First, we will talk about subsistence agriculture, followed by slash and burn agriculture, industrial agriculture, precision agriculture, sustainable agriculture, urban/peri-urban agriculture, community-supported agriculture, organic agriculture, and biodynamic ecological agriculture, followed by conservation agriculture. Now, these are actually organized not in a specific way, but I kind of organized them in terms of flow, because one form of agriculture typically leads to another. So we'll start with the first one, which is subsistence agriculture. This was the most common type of agriculture, and this is the original type of agriculture that arose back in the Mesopotamian era when agriculture first allowed people to develop civilizations. Subsistence agriculture is focused on self-sufficiency, or basically providing enough food for the self and the family. So the focus is on year-to-year survival and not actually upon producing enough food to be able to sell and market to other people. So producing enough food for family, however, that might occasionally include trade. So trade is important in an agricultural society because there are certain things that you do need that you cannot necessarily produce on your farm, such as medical care. If you needed medical care and you were a farmer, you would typically trade something such as a cow or some gourds or a bag of sugar or whatever you could actually produce in terms of or in exchange for the medical care that you needed. And not just medical care, but also tools and equipment. The United States was actually founded on this barter system of economy. However, this isn't so much common in the United States anymore, or even in Europe. The only places that a barter system of trade is actually currently being used, in which subsistence agriculture is still particularly common, would include Africa, Asia, and Latin America. Now, that said, there are some people who try to engage in subsistence agriculture for personal or cultural beliefs. For example, homesteaders in Alaska, or some people just choose to live on a farm and try to raise everything that they need for themselves. But this isn't the norm. And in terms of talking about a wide-scale cultural perspective, subsistence agriculture is predominantly limited to areas where individuals don't have a lot of access to urban jobs or infrastructure, and it's just about living in a particular area and producing enough resources to survive from year to year. The next type of agriculture that we'll discuss is slash and burn agriculture. This is another type of agriculture that is actually, it's been around for an extremely long time, from the time that the Mayas inhabited South America, but even before then it was found in parts of Asia, specifically Southeast Asia. Slash and burn agriculture is cutting down or burning of vegetated land to create fields for crops and livestock. This is particularly done in tropical locations because the vegetation is so dense that actually clearing the vegetation by hand or even with equipment is an extremely daunting task. So for people who don't have access to things like bulldozers, the easiest way to clear a field is to actually alight the field, to catch it on fire, to burn away the vegetation, which then leaves an open area. It also falls back on the primitive or less modern forms of agriculture, which used ash as a form of fertilizer. The problems with this is that This type of agriculture releases nutrients to the soil in mass, and they're very quickly depleted by the subsequent crops. Not only that, but the heat from the burning depletes soil microbial life, which plays a very important role in sustainability. The final thing is that when you completely clear an area, that area, especially if it has any slope whatsoever, faces a significant amount of erosion. As you can see in this image here, this is a picture that is showing an area in South America that has been cleared using the slash and burn method. And you can see evidence of the ash on the ground. So this area has not actually been farmed yet. And if it is farmed, chances are that it will only probably have 1 to 2 years of actual production, because after that the soil nutrients will be depleted. You have to remember that slash and burn agriculture is most common in tropical areas due to the density of the vegetation. But thinking about that, you have to also consider that these areas, even though looking at it, it would appear that the vegetation is extremely lush and this area must be nutrient rich, most of the nutrients are actually contained within the plants themselves. The soil layers are fairly shallow and the nutrient depth is not very deep because the forest itself relies upon that constant replenishment that comes from the dropping and decaying of leaves and other organic layers from above. So once you remove those other organic layers, there is no new input of nutrients into the system and it quickly becomes barren. We'll now talk about industrial agriculture. Industrial agriculture is one of the most prevalent forms of agriculture worldwide in developed nations currently. Industrial agriculture is the production of crops, livestock, poultry, and fish using large-scale methods that minimize costs, increase yields, and also work towards meeting the needs of a supply and demand economy. Here we're seeing a large-scale fish farm. We don't think about that most of the fish that we actually eat in supermarkets now really isn't raised in the wild. Most of that fish actually comes from industrial agriculture. So we have these large-scale fish ponds where the fish are raised and they're actually brought to market. They never actually live in an actual wild environment. Industrial agriculture tends to be technology intensive, meaning that it requires a great deal of large-scale machinery in order to be able to carry on the scale of farming that's actually necessary to successfully farm thousands and thousands of acres of arable land. It also requires genetic modification, a great deal of chemicals in the forms of pesticides, herbicides, and fungicides, and it's been criticized for the actual production impacts, and we'll talk about those in just a minute. Industrial agriculture is also very economically driven. So rather than just looking at subsistence farming, so we talked about subsistence farming as people who are trying to produce for themselves. If you're trying to produce for other people and make a living doing this, you have to consider the capitalist economy, which suggests that supply and demand have a common crossing point that is the maximum production level. So in terms of industrial agriculture, those who participate in this are very interested in markets and consumption. What is the market? So what is the demand that's out there? What do people need? And how much of that can be produced efficiently? Industrial agriculture, again, is very common in developed nations and it accounts for actually most of the food that you find in your supermarkets. So whether you are opposed or unopposed to industrial agriculture, you have to consider that every time you step into your local Walmart or Kroger or Food City, you're actually buying those foods that have probably been produced using industrial agricultural methods. Now, the criticism for production impacts comes from the fact that these types of farms typically are fairly intense in terms of the amounts of pesticides, herbicides, and fungicides that they apply to crops. Also for things such as genetic modification of organisms, which is basically just fancy hybridization. It's nothing new, but a lot of people have lots of issues with that. And we'll save that for another video later on in this unit. But let's think about that for just a minute. We're talking about the intensity of the inputs into an industrial agricultural system. That actually leads us very nicely or segues of agriculture, which is precision agriculture. So stemming from industrial agriculture, it isn't new to farmers that pesticides and herbicides and fungicides and fertilizers from runoff from the production of livestock entering stream systems or flowing across land is a problem. And it isn't that farmers are immune to these things. or that they don't care. It's just that people have to use what they have at the time to make a living based on their unique set of circumstances. And so precision agriculture is moving towards our next type of agriculture, which we'll get to in a minute. But precision agriculture recognizes the limitations and problems associated with industrial agriculture. And basically what precision agriculture does. So what precision agriculture allows for is, let's take a look at this map. This is a very interesting map because this is actually an individual field. This is a crop field. Specifically, this one is showing soybeans, but you can do this type of crop map for any particular field. This crop map is based on infrared imagery, where plants that are photosynthesizing at a greater rate or are healthier are going to be shown in a darker green, where plants who are experiencing lower productivity or chlorosis or any other thing that would result in an unhealthy plant doesn't reflect well on infrared imagery. So if you look at the actual scale here, which is important because remember, one of the things that we're trying to do in environmental science is learn to interpret graphs and charts and look at things from an actual scientific perspective. So here's a nice set of data. So if you look at the graph in the lower left, we see that we have an estimated dry volume in bushels per acre production for a soybean field. The areas that are the darkest green are the most productive areas of the field. The areas that are red obviously are extremely low. So we actually range from 61.2 bushels per acre in the most productive areas to actually 5 or less bushels per acre in the less productive areas. Now, obviously, the less productive areas should be targeted in terms of applying pesticides, fungicides, herbicides, whatever the actual problem is, which the farmer would actually have to go to that location in the field and determine what is causing the specific problem. But being able to identify the actual location to look is a big starting point. So what these maps actually allow farmers to do is to map their field. And you see that it is kind of pixelated. And this pixel is actually converted by way of a GPS to information that can actually be input into the GPS in a tractor or in the fertilization device. So what this allows the farmer to do is as he drives across his field, adjusted for speed. So if he's driving faster, it will spew the fertilizer, pesticide, herbicide, whatever at a faster rate. Or if he's driving slower, it'll be at a slower rate. It depends on the terrain. He can actually use what's called precision agriculture, which means that there are fertilization spigots or openings on the tractor or farm implement itself that allow for variable rates of application. And it's so precise that a single tractor that has a significant number, let's look at this next picture, has a significant number of openings. Each of those individual sprayers can adjust its own flow rate through a computer system that's actually located in the cab of the tractor, but it's more connected to a program that was preset before the farmer went out in the field. So using GPS coordinates, the actual sprayer adjusts so that the amount of pesticide, fungicide, herbicide is actually specific for the area of the field where the tractor is located. So were the tractor going over one of the red spots where things weren't going well, the farmer would have to go out and ground truth it and say, well, it looks like chlorosis, and so it looks like it's probably a fertilization issue. Or he could go out there and see that it looked like a bunch of little bugs were happily munching away on the plants, in which case it's a pesticide issue. Or maybe there are some weeds in that area that are competing with the plant, and so the plant isn't doing well, in which case it's an herbicide issue. As he passes over that area, after he's entered what he actually wants to apply to that area, using a GPS will direct the tractor to specifically spray a certain amount and concentration of chemicals in that area. If he slows down, the spray rate will slow down. If he speeds up, the spray rate will speed up to ensure that there's a consistent and very accurate application of the fertilization or other chemicals that are needed there. And so precision agriculture really is a way of trying to ensure that just what is needed is applied to the crops. And this is very important from an environmental science perspective because we want to make sure that we're not over applying chemicals. That's when too many things enter the runoff. That's when too many things enter the groundwater. When we're applying more than we need, whatever the plants can't take up just becomes runoff. Where if we're applying only what we need, in the event that the plants are able to take it up, we're maximizing our productivity and we are minimizing the waste and runoff. And that leads to, which is sustainable agriculture. I think the ultimate goal of most farmers is sustainable agriculture. Because in my own personal experience, as well as the experience of many people who work in agriculture, people who own land and have worked land and the land has been in their families actually care about the land more than most people. And so it's a myth that farmers are really out there trying to destroy the environment to plant genetically modified corn. That's not the case. People definitely have to make a profit, but farmers want to engage in sustainable methods because they actually care about the environment in which they were most typically raised and that they encounter every day. Most farmers are much more in tune to wildlife than most of us in the city, that we think of ourselves as caring about things like panda bears and polar bears and all those sorts of organisms, which certainly are important, but we don't actually interact with those on a daily basis. And so we definitely don't probably have the buy-in that most farmers do with their own agricultural land. So let's take a minute to think about sustainable agriculture. Sustainable agriculture is the idea behind it is to move towards is looking at farms that can produce food indefinitely, foods or crops indefinitely without causing major damage to ecosystem health. So the sustainable agriculture model is kind of a live and let live. So it aims to allow farmers to produce crops and to maintain a living on their properties, but at the same time providing a certain amount of protection for the ecosystem so that you have kind of a balance. So the three main goals of sustainable agriculture are environmental stewardship, which include things like, if you look at the bottom left of this image, we see this riparian buffer area. And it's really what it does is it provides a zone between the agricultural area and the surrounding areas. And not only does it provide a zone of protection from things like chemicals from runoff, but also provides a lot of habitat for things such as small birds and rodents, many insects. And many insects, remember, are extremely important in the prevention of crop infestations, as well as providing habitat for things like foxes and coyotes, and birds of prey would certainly hunt in that area. So there's a huge ecological benefit there. The other goal is farm profitability. So farm profitability is important. If you're a farmer, you can't just. So that leads me to my next one, which is urban peri-urban agriculture. This one is growing greatly in modern time. So urban peri-urban agriculture is kind of the answer to urban society. As the human population increases, there's a limited amount of land in which people can inhabit and grow food and raise families and build homes. And for the most part, many people tend to be crowded, as we've talked about previously, around urban areas. In many very large cities, that's actually where the jobs are. People actually leave rural areas and farming because that is so unpredictable, and they actually move towards urban areas, which is where there are specific jobs that they might actually have an opportunity of obtaining. In urban agriculture, the focus is on cultivating, processing, and distributing food either in, which is urban, or around, which is peri-urban, cities, villages, townships, etc. So the ultimate purpose is income or personal food production. So some people actually engage in urban farming in order to produce food that they intend to sell to other people. Many people engage in urban agriculture simply to actually produce food for themselves. Beyond the urban aspects, there are actually social aspects associated with urban gardening. It's actually many times a community effort where people come together and it's something that they do in their spare time. It addresses some of the concerns from things such as nature deficit disorder, where people in urban areas actually don't get a lot of opportunities to engage with nature. And we have found this actually alters the brain significantly, and it can lead to depression, anxiety, and other things. There's also a lot that you lose from an understanding standpoint in terms of worldview if you don't ever engage with anything outside of the urban environment. Urban environments also can provide a source of local foods. So increasingly people are engaging in urban agriculture to produce herbs and peppers and lettuces and plants that they may sell to restaurants or they may use themselves. But finally, the thing not to be overlooked is that urban agriculture is very likely a solution to the problems that we face as a global society as the earth becomes more populated. How can we actually produce enough food for people based on the land constraints. So we see things such as the previous slide and this slide that show vertical gardening, where the actual outsides of buildings are being used as an agricultural platform. There have been some proposals recently that actually that design entire skyscrapers, and the entire skyscraper is basically a large virtual farm. So instead of taking up thousands of acres of land or thousands of square miles of land, it is actually built in an upward direction so that the land restrictions or the land needs actually don't spread. They move in an upward direction, which upward in terms of engineering has some constraints, but definitely has a lot fewer constraints than actually needing land in an urban environment. So I think we're going to be seeing a lot more of this in the future. So wrapping up, we have community-supported agriculture. This relates again to the urban agriculture because this would be kind of smaller scale farmers that produce locally grown foods, locally grown produce, locally grown livestock, and they sell it in markets that commonly are called co-ops. So the way that these work is that it's a marketing alternative that allows small-scale growers the opportunity to actually bring their goods to market. Typically, customers pre-enroll and they receive either a weekly bag or a box, and it will be whatever is the fresh local produce or even meats that have been grown around that area. So you sign up ahead of time, and basically whatever is in season is doled out in these boxes, and you get to take one home at the end of the day. And much of that is provided by local growers. So it provides the local growers a market where they couldn't really compete with the large industrial types of agricultural formats, but also provides individuals the opportunity to use and consume locally grown produce, which typically is less pesticide and chemically dependent, but also doesn't require the shipping impacts on the planet that shipping produce from California or Florida or South America typically does. So you're eating seasonal vegetables, so they're fresh, and they're healthier because they're fresh, because you definitely lose vitamins and minerals when foods are left for long periods of time and unconsumed. But it also provides the type of opportunities for local growers to actually sell to the people around there, and it keeps the costs down. So most local growers are competing with big agricultural, industrial agriculture, which have low prices because they produce a lot. The only way to really avoid this is if you can sell your products to people locally. You can keep your costs down because you don't have the transportation costs associated with it. So it provides kind of an evening out of the competition. So that's how community-supported agriculture works. We have several co-ops around the Knoxville area. You'll notice if you go to Tri-Cities Market, Three Rivers Market, and also the farmers markets around here, those all support community agriculture incentives. And we have several opportunities that individuals can sign up for to actually receive weekly or monthly bags and boxes. So just a couple more to go. Organic agriculture. I'm not going to spend too much time on this because we actually have to consider this in a lot more detail later on in this particular unit. Organic agriculture basically tries to sustain natural health of soils, ecosystems, and people using principles of ecology, biodiversity, and natural biogeochemical cycles rather than using things such as pesticides, herbicides, and fungicides, or using natural forms of those. It's a little bit controversial, as we'll explain in a later video, because it's pretty labor intensive. They're usually smaller yields, and for those reasons, it's pretty expensive in terms of large scale agriculture. But we'll talk about later where organic agriculture fits into the larger picture. But again, it's based on ecological principles of how nature sustains itself. We have biodynamic ecological agriculture, which is kind of our woo-woo agriculture, because it's based on things like looking at astronomical charts and looking at spiritual worldviews. So it's kind of taking a holistic perspective to agriculture, where it says that everything in the farm is interrelated. It's looking at it from a spiritual dynamic. And there isn't any scientific support for these types of principles, such as using astronomical sowing and planting calendars. But it probably does have roots in seasons, which would be things like looking at the length of days and things like that. So we don't spend a lot of time on that one. Conservation agriculture is the last one we're going to talk about. And this is an increasingly important one because there are lots of agricultural programs that actually either benefit from or use conservation programs as a part of their overall agricultural goals. As a matter of fact, if you look at this field, you see this ditch right here at the top left, and it's actually a creek. So that ditch is actually there. The grass has been left growing to actually protect the creek from runoff from this agricultural field. You'll also see that there's what is called no-till farming, which means that you leave the mass, you leave the stems and the sprouts in the field, you harvest what you need, and everything else is left standing there, and then it's kind of pushed down and flattened out so that it doesn't interfere with photosynthesis of new plants, but it provides a natural form of fertilizer. Conservation agriculture attempts to balance profit with environmental stewardship. So you have programs like USDA farming programs, Fish Wildlife Service landowner incentive programs. The ultimate goal is to provide minimal soil disturbance, mineral maintenance, and as well as to maintain a permanent soil cover, which is extremely important in terms of erosion prevention and loss of nutrients. It also protects water because it keeps runoff, the actual detritus in the fields, which would be the leftover stalks and things in the fields, actually protects the fields from losing the nutrients that are in there. And finally, it emphasizes things such as crop rotation, like what you're seeing in this particular picture. There were beans growing and they've been cut down and mulched into the soil. The soil hasn't been disturbed, it's just been cut down, it's laying on the top, so it will naturally compost itself over time. And you see that there's corn growing in there, so corn, bean, cotton rotations are very common. There's also the protection of habitat zones.